Alright, so lastly, let's talk about piecewise function. So what is a piecewise function? So piecewise function is basically a function which is defined by multiple subfunctions, meaning that at different value of x, so you would have different function for each of the cases. Okay, for example, if I were to refer to this graph right here, so basically this is, how many functions is this? I think it's at most is going to be 4. So this is going to be one function. So this is going to be the second one, the third one. This is actually the fourth one, and this is actually the fifth. So there is actually like 5 functions altogether here. So at different value of x, so there will be different function. Okay, and the most popular thing to be asked for piecewise question is that first you're going to sketch it, and the second is that you're going to find the domain and range. So while we are at it, like looking at this function right here, so let's try to identify what is going to be the domain and range for this case right here. And this, let me put an arrow. So arrow means that it goes on forever. So we know that the value is going to extend until negative infinity. So the value of x is going to be from a negative infinity, okay, until infinity. If we have a look over here, so it goes like forever and ever. Okay, however, I would like to highlight to you the fact that there are holes here. So where are the holes? It would be here. So remember what happened is that when you use this symbol, so meaning that that number over there is included. It's what do you call that? A full circle. But if you have an empty circle like this, so meaning that whatever number that goes there, it is not included. And for this case, it doesn't matter because we have one included, one not included, meaning that it's included anyway. But our concern is going to be this one, for which both values of 1 is not included. So that is why for this case, when we write down our domain, so we have to point out that it goes from negative infinity until infinity. However, number 1 is not included. So it's going to be from negative infinity until 1. So union from 1 until infinity. So we have seen something like this before, or we can write that. So it's going to be x is going to be Fourier number, so such that x cannot take a value of 0. So that's fine as well. So you have 2 notations that you can use. Either you can write it in terms of a union like this, or you can write it in terms of set notation. So either way is correct. And what about the range? So let me clean this so we can see the range, or else we wouldn't be able to. So when we see the range, when we have a look at domain, we refer to the x-axis. So here, so domain refer to the x-axis. But when we have a look at the range, we are going to refer to the y-axis. So let's have a look at the y-axis. So when I have a look over here, so it doesn't really covers everything. So this is where the maximum value is. However, I would like you to notice the fact that the maximum value is going to be at 2, but 2 is not included. So it's going to be an open bracket right there. And does the value extends? Yes, it stops here, but it extends until negative infinity. This extends as well, so there is no hole basically. And all values are included because of this function, except for 2, because of this function right here, see? So this function, it covers everything. So basically, for this case, when I have a look at the y-axis, what values are being included? So the minimum value so goes actually from negative infinity, but the maximum value is going to be 2, but 2 is not included. So that is going to be our range. Okay, now let's have a look at these 2 functions. I'm going to show you the example. For the case of A, so I have a function f of x equal 1 from x less than 0, and it's going to be negative 1 for x greater than or equal 0. Okay, let me remind you again for the case of what do you call that, a function of a constant. Remember, we have y equal mx plus c. But when you have your function in terms of, for example, y equal 3, so what happens is that your function is actually y is equal 0x plus 3. So the gradient is actually equal 0. And we know that when gradient is equal 0, so the graph is not going up, it is not going down. Okay, let me show you. For example, this is going to be my axis. So if I have, let's say this is going to be number 3. So this is everywhere that is here. So this is going to be the graph of y equal 3. Because everywhere along this dotted line, is going to be y equal 3. And if I wanted to sketch what is going to be y equal 1, for example, so this is going to be y equal 1. So it's going to be a horizontal line at the value of y equal 1. So that is how you sketch graph of constant, because it's not going up, it's not going down, so it's going to be a horizontal line. Okay, now let's start sketching this. It's going to be 1 and negative 1. So this is going to be my x-axis. This is going to be my f of x. So I'm going to put here as being negative 1 and up here as being a value of 1. So the thing is that I have to be mindful about the range, about the interval. So when x is equal 0, so the function is going to equal 1. But if 0 included, no, 0 is not included. So I have to use the empty circle. So this is going to be my empty circle. So it's going to extend over here. So this is going to be my graph of y equal 1. But we only start from here because it should be the value when x is less than 0. And where is x is less than 0? From here. Okay, and 0 is not included. And I'm going to do the same. But now for y equal negative of 1. So it's going to be at y equal negative 1. But now x is actually included. So it's going to extend a horizontal line. Okay, now that we know that this is how the graph is going to look like, so next what we're going to do is, for example, if I'm going to explain to you this concept clearly. So let's try to figure out what is going to be the domain and range given what you have sketched over here. So the domain, so when we talk about domain, so we're going to refer to the x values. So what x values is being covered, if you notice. So this is going to be my x-axis. So there goes my x-axis. And if you notice, so this line actually extend to negative infinity, and this line actually extend until infinity. So that is why basically all values are being covered. Let me erase this, erase highlighter. Okay, and get back to that. So therefore, like all values are covered along the x-axis. So therefore, even though we have a hole, but here one is not covered, one is covered, but we consider that the value of x is being covered. So therefore, my domain is going to be all value of x. So it's going to be, I can write it either from negative infinity to infinity. So I can write that x is the subset of all real numbers. Okay, or, so either way is correct to write the domain as this form or this form. So that is going to be in terms of domain. Now let's talk in terms of the range. So when we talk about range, we have a look at the y-axis. So what value is being covered in the y-axis? Okay, however, if you have a look along the y-axis, which is going to be here, so only two values are covered. There is a big hole going on here. So that is a hole all the way from here to here. So there is no line of the functions right there. So therefore what happened is that it's the value of y is only covered at two places, so which is going to be, so this is not x, so this actually only happens at y equal 1 and also y equal negative of 1. So that's why when I write the range, so my range is simply going to be for negative 1 and also 1. So we have specific values, that's it. Okay, because there's a hole like everywhere here, there is no line at all, so meaning that so the function doesn't cover all those values, only at negative 1 and 1. So that's the first function. So let me use, no, I don't want that, that's not what I meant to do. Okay, let's have a look at B. So what is the B question? Okay, so we have two functions. The first one is y equal x plus 5. So y equal x plus 5. So we can do that side by side. Okay, this is simply a linear function. So what happens is that my gradient value is going to be 1 and the intercept value is going to equal 5. So if I were to sketch this graph, I know that it's going to intersect over here at a value of 5. And what is going to be the intercept on the x-axis? So this is going to be the x-intercept is when y is equal 0. And if I were to calculate, I will get that x plus 5 is equal 0. So my x-intercept will be at negative of 5. For example, let's say this is going to be negative of 5. So all I have to do is connect these two lines right here. So that is going to be my graph for y equal x plus 5. However, if you have a look very closely at the interval, So my graph of x plus 5 is only supposed to cover for which x is less than -2. So where is x equal -2? So let's say somewhere over here. So this is going to be x equal -2. And what happened is that y is equal, when I substitute the value of x equal -2, I'm going to have -2 plus 5. So my value is going to be 3. So when x is equal -2, my y coordinate is going to equal 3. So somewhere over here, this is going to be a value of 3. And because we only need this when x is less than -2, not included. So therefore, I only have to take this. This is going to be the line that we need. We don't need the rest of them. Okay, so that is going to be the example. And then that is the first function. The second function is going to be x squared plus 2x plus 3. So this is going to be y equal x squared plus 2x plus 3. So we know that the y-intercept is going to be at 0, 3. And because here a is greater than 1, so this is going to be a small graph. So we can have a minimum value. So how do we calculate the minimum value? For the x-axis, it's going to be, for the x coordinate, it's going to be -b over 2a, which for this case is going to be -2 over 2 multiplied by 1, and that is going to be -1. And as for the y coordinate, so what I have to do is, I have to find what is going to be f of -1. And when I substitute into this equal -1, so I'll end up with -1 squared, so that's 1 plus 2 multiplied by -1, that's a -2 plus 3. So therefore, I will get a value of 4 minus 2, so that's a 2. So my coordinate, the minimum value, so it's going to be at -1, 2. Okay, so basically we have the information already. And if I were to sketch this, so my minimum value is going to be at -1, 2 is going to be somewhere over here. So this is going to be my minimum value. So this is where the minimum is, and it's going to intercept at 3. So let's say this is 2 and this is going to be 3. So this is where the intersection happens. So my graph is going to look like this. Okay, however, again, so let's have a look at the interval. So we only wanted this function when x is greater than or equal -2. So where is -2? So we have to spot that on our graph. So what is going to be the value here? This is going to be, what is coordinate value? So -1, 2. So what happened when this is -2, when I substitute f of -2, so that is going to equal -2 squared, so that's a 4 minus 4 plus 3. So 4 minus 4 plus 3, I'll have a value of 3. So meaning that this is -2, 3 is going to be somewhere over there. So when we wanted x when it is greater than or equal -2, so we're going to take this function onwards. So that is how the graph is supposed to look like. Now all we have to do is, so combine these two things right here. Okay, so I'll do the combination down here. So -2 somewhere over here. And my graph at that point, so -2, this is what value just now? This is a value of 3. So here, let's see, this is going to be a value of 3. So it is not included. So I'm going to put a empty circle, and the intercept is going to be at -5. So let's see, somewhere over here is -5. Now all I have to do is connect it like this. So that's going to be my first function. And then I'm going to deal with the first function. So what happened with this second function is that I'm going to use blue. The coordinate of when it is -2, so the coordinate is going to be -2, 3. So which kind of overlap for this case means that I'm going to have another full circle but at the same place, and the minimum value is going to be at -1, 2. That's it, it's going to be somewhere over here. This is my minimum value, and the intercept is going to be somewhere over here, which is going to equal 5. So when I put my graph together, so it's going to look something like this. Okay, so I basically patched together, so this one and this one, combine them. So this is how my graph is going to look like. And now suppose the question asks you for domain and range. I can write that the domain, when I have a look at the x exists, it covers everywhere, because this is going to go to its positive infinity, this is going to go to its negative infinity. So the domain is from negative infinity until infinity. And the same goes for range, because so this is now covered. Since one is covered, one is not covered, so therefore 3 is basically covered now. So the range is also going to be from negative infinity until infinity. So I hope the idea of like how to find the domain and range is clear for you. But if you still have problem identifying domain and range from graph, we can actually pick some problems and discuss it together during our online session. Okay, and there's a bunch of